Yes, good afternoon. I'm Alexa Schmitz. I'm the CEO of REEgen. And earlier this year, my co-founder, Sean Medina, and I formed our company in order to sustainably regenerate the US rare earth economy. Since I was young, I've imagined a future with unlimited sustainable energy. I was really inspired by this view of the windmills by the side of the road as I drove to and from college in Pennsylvania. But behind the promise and the beauty of sustainable energy infrastructure are the critical materials that are needed to build it. So these rare earth elements, they're the lanthanide series along the bottom of the periodic table, the top row, scandium and yttrium. And they all have really important properties that make them essential for many of today's modern electronics, including your mobile phones and many of your laps and computers. But they're super important to make the really strong, lightweight magnets that are going to confer the efficiency of windmill turbines, electric cars, and solar power stations, among other things. So with all of these uses coming around today, the global market for rare earth elements is rapidly rising. So these gray bars show how that demand has risen over the years and will continue rising. The black line is demonstrating where it was in 2021. So it was still more than the demand, but the supply will no longer stay above demand, which will outpace it in the next few years. Furthermore, one key factor is that China is dominating the market. They control 60% of the rare earth elements right now. And not a big deal, except political tensions rising are leading to supply risk. So the reason that this is the case is because the environmental impacts of mining rare earth elements has actually driven all mining of the rare earths out of the United States. The reason is that a ton of rare earth elements, which is about what you need for a windmill turbine, can generate a disproportionate amount of hazardous waste gas, sewage water, and a lot of radioactive waste as well, and has the equivalent carbon footprint of about 45 tons of CO2 equivalent. So my co-founder and I did the National I-Corps program this summer and spoke to lots of customers and identified two in particular that are really having some pain points from these two issues. We have a lot of rare earth buyers in the United States that are complaining about the volatile prices and unreliable supply because of the US dependence on China for imports. Furthermore, we spoke to a bunch of feedstock suppliers, so customers with rare earth sources that are looking for a sustainable recovery method that they can use to recover these valuable metals out of the sources to offset some of the costs of waste disposal. So at REEgen, we're actually building that sustainable rare earth recovery system using clean biological methods. Our process begins with bacteria that convert glucose into biodegradable organic acids, which we call a biolixiviant. We use this biolixiviant then to extract metals from rare earth solid sources, and then we can use a rare earth specific binding biofilm in columns to recover total rare earths. We're improving all of this efficiency using genetic engineering. We then take a mixture of rare earths and we separate it into the individual elements using engineered bacteria that each are able to bind a specific rare earth element to their membranes. So this solution is in fact replacing the two most hazardous steps in our competitors' traditional processes. The bioleaching with microbes in the green on the right is replacing the thermochemical leaching that has lots of harsh sulfuric acid necessary and high temperatures, whereas we have biodegradable acids and room temperature. Furthermore, our bacteria for biological separations is eliminating the need for tons of solvents used for the extractions that can pull the individual elements apart in traditional processes. Additionally, by tapping into recycled waste streams and waste for recycled rare earths, we hope to alleviate many of the future impacts of the uptick in mining that's going to be necessary to meet this rapidly rising demand. So just as one example, coal ash. It has high levels of neodymium, dysprosium, and terbium. These are three rare earth elements that are essential for making the magnets and windmill turbines. The United States is actually still producing over 100 million tons of coal ash on a yearly basis, but there are over 1.5 billion tons of coal ash stockpiled still. So only half of that, we could get rare earths from half of that to make enough windmills to power New York City. So with this in mind, at REEgen, we have the vision to secure the future of widespread sustainable energy through the implementation of low-cost environmental friendly biological processes for recycling, recovery, and production of rare earth elements. So right now, we're small still, and we're about able to make 1 milligram of mixed rare earth elements per week just using Erlenmeyer flasks. REEgen is just founded, and we're just starting in our lab, and with some money from Activate, we're going to buy a benchtop bioreactor that will allow us to maximize efficiency and scale up rapidly. By 12 months, we want to bring that to 10 milligrams per month or per week. And then over the course of the next 5 years, we will continue to scale up. And our hope is to turn that 10 milligrams into 10 kilograms in 5 years, which is about the production level that is necessary to have market entry as a reliable source. So we're new, so our team is still small, but we've got big ideas about how to really push the boundaries of what is possible for the recovery of rare earth elements. We have support from the Activate, Cornell, Praxis Center communities, and several funding sources already. So this is allowing us to grow quickly and rapidly accelerate towards that goal. We are assembling our advisory board at the moment, and just this week, we actually got Marty Weems, the CEO of Western Rare Earths, on board. He is an expert not just in rare earth mining, but all things rare earths. Which brings me to my ask today. Connect with us. Reach out to me, reach out to my CTO and co-founder. We're looking for advisors, mentors, partners, and really any type of feedback. So if you have anything to offer, we would really love to hear from you. Thank you so much for your attention.
Yeah, hi. Thank you. I just have a question. It seems like, where are you in the status of the technology in the terms of, you're saying you're making a little bit up? Has this been proven as a scientific, or is this still a moonshot project?
It's proven, it's prototyped. What we haven't done yet is actually crash the rare earths out and create the oxides, but that's already pretty basic demonstration. But what we've done is we've extracted large amounts from a solid source using our system and then shown how much is in a small amount of liquid. So more or less, it's prototyped, but a very small scale.
Okay.
Does that answer your question?
Yeah, so I was wondering, what is, in terms of the challenge to the business, is it actually just getting it to scale, or is it proving that the technology actually works?
Yeah, that's a great question. So twofold, both of those things, but the very first thing that I want to be able to put into place in the next 12 months is, I mentioned the biofilm column that can pull out total rare earth elements. That's also been prototyped, and it's with a collaborator. What I want to do is link those two steps together. So we can leach total rare earths and then use this biofilm column to pull them out. And I just want to make sure that what I get out of my process with bioextractions is going to work with the column. And then once that's done, it's just a matter of scaling it up and then delivering that process to the customer.
Which leads to the next question. So what's the customer acquisition strategy?
Well, currently, we're focusing more on potential partners that we could do pilot experiments with. So we've spoken to several customers. It's weird to call them customers, but people who have feedstocks and they want to get the rare earths out. So you have environmental directors at utilities companies, and they've got a lot of waste that some of it goes into cement industry, in fact, and that's a whole other cool story. But they want to be able to offset those expenses by getting the rare earths out. So working closely with 1 or 2 utilities companies, we already have non-disclosure agreements and material agreements in order to get, and I have a big bucket of coal ash that showed up on my front porch, which was awesome. We're going to work with them to see if we can make that process really economic for them so that they can use it to clean up their landfills, to get rare earths out of the coal ash that can't go into cement, or even get it out and then send it to cement. So that's one example, but we also have BASF is looking for somebody to recycle it out of their slag from auto catalysts that have rare earths in them. So those are the types of customers we're focusing on now. But then as our separations to individual rare earths come later in the next couple of years, I didn't talk about it so much on the timeline because there's not enough time, but that's where we want to do our own production facility. And that would probably come after we can deal with customers who want to extract it directly. We're going to build our own facility to start generating pure rare earths. And then we'll reach out to more customers for direct sales. Yeah.
Question. Given the toxicity, where would you be doing this? Where would your production facility be? At your clients, or you said you're going to have your own production facility? That's obviously not something you can just do anywhere.
So in terms of toxicity, all of our compounds that we're putting into it are non-toxic. But then when you're dealing with certain waste products, they can have toxicity. So in the case where, say, you have So not all coal ash is actually toxic, by the way. Some of it, you can get the regulations and permits. We've spoken to regulators in probably about 10 different states in the United States to talk about what that would look like. But in the case where we have something toxic, and actually just generally, we're trying to keep the waste owned by the waste holder. And then we're providing a service, a process for them to purchase from us, to contract us to maintain, and then we'll figure out how to split the process. On-site, absolutely. Even still, transportation would be prohibitive to take it very far away. Yeah. Great, thank you.
Excellent. Thank you so much.
Wonderful, thank you. It's a pleasure.